Well, welcome everyone. Thank you so much for joining today. My name is Katie and I'm the PMM for Unfolded, and I'll be kicking us off today. Ilya, next slide. Today I am joined by two of our rockstar engineers, Ilya Boyadin and Shun Lee. And before we get started, I did want to call out that we will be hosting a fireside chat on the Unfolded Slack channel where you can ask all of your burning questions, and more details on that will come at the very end of the presentation, so stick around. So for those of you who may be unfamiliar, what is Unfolded? Unfolded is a geospatial visual analytics platform that powers large-scale analysis without compromising performance, speed, or interactivity, which are a few challenges you may come across with more traditional GIS platforms. And by joining forces with Foursquare, we can dream up new integrated solutions for businesses needing quality location data and a platform to make sense of it. And Unfolded has many advanced features that can be used to build a variety of geospatial solutions. But today we're just going to focus on how mobility data analysis and cluster and outlier analysis in an Unfolded Studio can reveal new insights around travel and demand. And with that, I will pass it off to Ilya.
Hello, everyone. Thanks, Katie, for the introduction. So I will speak about mobility data analysis and why I think that it's important. It's because many aspects of our lives and many real-world phenomena are about movement in space, like transport of people, goods, money, energy, information, everything that can move or be moved. And nowadays we have cheap sensors and data storage, and automated data collection is very simple. So we have lots and lots of new data sources producing and capturing mobility data. And decisions based on this data, for instance, about city planning or transportation infrastructure, resource allocation or site selection, they can be costly and they can potentially affect many people's lives and businesses. So to make sense of these vast amounts of data and to extract useful knowledge from them, we need adequate data analysis and exploration tools. And we are trying to build such tools and to add them to Unfolded Studio so that people can use them. And today I want to show you some of them. So there are different kinds of mobility data. Today I will speak about 4 of them for which we have support in Unfolded Studio. And the first one is called footfall data. These are aggregated counts of visits to particular locations. This kind of data can help answering basic questions like how many people are at different locations at different times. Imagine that you want to find a suitable location for a new store. So the number of people who would potentially visit your store would obviously be a very important factor for making this decision. And now I'd like to show you how it looks like live in Unfolded Studio. So I'm loading this map, which shows the numbers of taxi pickups in Chicago. And the numbers are spatially aggregated to H3 hexagons, which is a great way to simplify spatial data analysis by using a unified hierarchical system of hexagons. And H3 hexagons are natively supported by Unfolded Studio. Google for the power of hexagons in quotes to find the talk by our colleague Nick Rabinowitz explaining all about them. So this map was made from a single CSV file with these columns. H3 is the unique ID of the hexagon for which we counts were aggregated. Pickup date is the timestamp when the pickup happened, and trip count, the last column. The other 3 can be ignored. The trip count has the number of trips, the number of pickups which happened in this hexagon. So having these columns, we can visualize it as this map. And since we have the timestamps for the pickups, we can also play the animation over time to see how the numbers changed over time and how this happened across the city. So the second kind of mobility data I want to mention is called street flow, which represents through traffic by route segment. It can help answering questions like, where are the traffic bottlenecks, which can be important for transportation or urban planning, or how noisy are the streets, which can be useful, for instance, for site selection. So this example map shows the changes during one day in the number of trains passing through the railway segments in Switzerland. I'll try to show it live to you. So it was made from 2 files. Train count CS3 has the numbers of trains per segment. So we have the segment ID or HID, how is it called? It is called here, the timestamp and the number of trains passing through. And the second file is a GeoJSON file with the geometries of the segments themselves. And to combine the two, we can utilize the joining operation, which is available directly in Unfolded Studio. And we can join based on the HID or the segment ID. And the resulting data set will have all the columns we need in one place, in one table. So we have the geometry, the timestamp, and the number of trains passing by. And then we can visualize this using the polygon layer in Unfolded Studio. And apply the different colors to the segments by using the stroke color and picking the count column to base the stroke color on. And since we have the timestamps for the data, so this was actually based on the timetable for one single day, and we can play the animation and see how the number of trains changed during the day. So there were no trains during the night, and we can see in orange the segments where the busiest connections in Switzerland are. So the next kind of mobility data are movement traces, which is useful for instance for fleet management. If you're working at a delivery company, you might want to have a better overview over your fleet of vehicles to better understand whether it is utilized efficiently or not. Or maybe there are areas which are underserved, or maybe is there excess capacity somewhere which can be reallocated to a different place. So this could be about a fleet of taxis, delivery trucks, or even about planes, like in this example. So in this map, you see airplane flights over Europe in a view which is in a way similar to how an air traffic controller would look at it. And the data used to create it is a single table, single CSV file with the following columns. We have the ID of the plane. So there are two different kinds of IDs, but we only need one actually. The location, this is just a bunch of GPS locations for every plane. The timestamp, so when this particular plane was in this particular location. And we also have altitudes, which is optional. but in case of airplanes, it's useful. And having this single table, single CSV file, we can visualize these airplanes and how they fly over Europe. We have the trip layer in Unfolded Studio, trip layer, which we can configure by selecting the corresponding columns for the location, for the ID, for time, and for the altitude. And since we have the altitudes, we can even look at the planes in 3D to see when they were taking off or they were climbing or descending. So the last but not least kind of mobility data I want to talk about is origin destination data, or just OD data. These are aggregated numbers of movements between pairs of locations. And such data can be put to a table with the columns origin destination count. Here you see, for example, that 200 people traveled from West Village to Tribeca and 100 from Soho to Brooklyn. And this data could be displayed in a simple way using two separate maps, as you can see here. The left one showing how many people left from the different neighborhoods in total. The right one showing how many arrived to the same neighborhood. And these are basically two footfall maps, as we saw in the first example. But one is for the origins, the other for the destinations. So this kind of works, but we ignore this way the connections between the origins and destinations. We are only seeing the total numbers of incoming and outgoing moves for each neighborhood. So a more detailed representation of this kind of data is a flow map, which shows the numbers of people who moved by varying the thicknesses of the arrows connecting the origins and the destinations. The more people moved, the thicker the arrows. And this simple representation shows more effectively the true network structure of the data, so that you can immediately see which pairs of origins and destinations have strong connections. And flow maps can be very useful for analyzing and understanding the travel demand and answering questions about the movement patterns, like where are the most frequent travels? Where are the top destinations of travels from a particular location? When are the peak travel times if you have the temporal dimension in the data? Or how do travels differ for different modalities if you have mode of transport as an attribute in your dataset? And here I want to show you an example map with the data from the bicycle sharing system in Montreal. So here we see this flow map connecting the stations, and the thicker the flow map, the flow lines, the more people were traveling between the stations. We have the temporal dimension so that we can play the animation over time, and you can see like that in the mornings we have more people coming to the downtown city, and in the evening more people leaving. So in the circles we'll also show the total incoming or outgoing trips for the locations. And this way you can analyze quite complex data set. And we have implemented several techniques which make it possible to dynamically filter and aggregate data on the fly, which makes it easier to analyze larger data sets by showing a useful summary which adapts to the viewport. And yes, to visualize this data set, we don't need much. We need a single CSV file with the coordinates of the origin location, coordinates of the destination location, and the number of trips and the time column. So the last example I want to show today shows the short car trips with no passengers made in the Waterloo region in Canada. So imagine you are a city planner and you want to understand where it's best to invest into cycling infrastructure so that you can maximize the return on investment. And this is sometimes called active trip potential. So by understanding the travel demand for short trips, which are currently made by car, we can identify areas and connections with the highest potential to motivate people to cycle or walk instead of driving. So if we invest in better infrastructure for cyclists or pedestrians. And then in this map, you can immediately see where are the connections with high demand for short trips. Much change in the world is due to geographical movement. This is a quote from Waldo Toppler, who was the famous geographer and map maker, who was also particularly fond of making flow maps, as I also am. So many things in the world, many phenomena are about movement, mobility, and transportation. And if we want the right changes to happen, it's important that we analyze and understand these phenomena. And nowadays we have more tools at our disposal for doing that. And some of those I showed you today, so I hope it was useful and interesting for you. With that, I will pass it off to my colleague Shun, who will tell you all about cluster and outlier analysis in Unfolded Studio.
Thank you, Ilya. My name is Shun Li, and I'm a software engineer at Foursquare. Today, I'm going to talk about one of the many spatial analytic features in Studio, the cluster and outlier analysis module. So one of the common tasks in spatial analysis is to find the spatial patterns from your spatial data. So we can get some insights and knowledge from the patterns, like are similar values clustering in space, and where are they, and can we find them on the maps? So cluster and outlier analysis is a tool that can help you to find the statistically significant hotspots, cold spots, and spatial outliers on the map. This method has been widely used in special applications such as real estate research, criminology studies, public health research, and much more. So as we mentioned before in this talk, we are not only providing our customers with useful tools, but more importantly, the solutions to solve the real-world problems. The Foursquare provides the most trusted and independent spatial data that helps us to understand how people move. So this data drives the development of the spatial analysis in Unfolded Studio. So with this tool and the Foursquare data, we can use the cluster outlier analysis to answer questions like, are there spatial patterns in the listing price of Airbnb rentals in the city? Are there any restaurants with significantly more or fewer visits than nearby competitors? Which US counties have significantly higher COVID cases? Some of those questions. So there are some tools and software that can do cluster and outlier analysis. So what is unique about the cluster outlier analysis in Unfolded Studio? First of all, is the first browser-based cluster analysis, which means it is cross-platform and everything runs fast in your browser. You don't need to install anything to run it. And the second is about its performance. It has a fast algorithm design and implementation, which means it runs much faster than any other tool. Last is for big data. So the cluster analysis in Studio is designed to work with big data using Excel. So we'll have the chance to do cluster analysis for real big data sets. So the method we used to implement the cluster analysis is the local indicators of a spatial association, specifically the local Moran statistic, which is developed by Dr. Luke Ansling in 1995. It is one of the most used methods for cluster analysis, and I will illustrate how this method works to find cluster outliers from the spatial data.
Hey, Shun. Hey, Shun, can you reshare your slides? Yeah.
Yeah, let me reshare the slide a little bit.
Looks like they're cut off for some reason. Okay, that's better.
Okay.
Thanks.
Thank you. Yeah, this is good because I need to show all that four small charts. So suppose we have some data from one variable, for example, the crime rates. And in some cities, the data values are in one-dimensional space. And there are low values and high values. If we examine these values in geographical space, one thing we can check for each data point is we can compare its data point value to the nearest neighbors. For example, compare the one data point with the mean value of the 4 nearest neighbors. Then we will have the mean values from the neighbors for each data point for the data points neighbors. So then this allows us to expand from the one-dimensional space to a two-dimensional space. From here, you can see there's a linear relationship between each data point and its neighbor data points. In this example, we can see there is a positive trend that the data points with high values have neighbors with high values, and data points with low values also have the neighbors with low values. So this positive trend is also called a positive spatial autocorrelation. If there's a negative trend, which is shown in here, that means that if the data points with high values and it has neighbors with low values. When the data points with low values, it has neighbors with high values. So this is also called negative spatial autocorrelation. In local Moran statistic and conditional-based permutation test against the null hypothesis of a spatial randomness is applied to get a pseudo p-value for each data point. Then the significant data point can be classified into 4 categories. The red ones are a high cluster, which means data points with high values are surrounded by neighbors with high values. The blue ones are the low clusters, which means data point with low values is surrounded by neighbors with low values. And we have special outliers, which are the pink ones, means and the data points with high value have neighbors with low value. And with the light blue one means the data point with low value has neighbors with high values. So this will be highlighted and saved. So this results will be saved in the table and highlighted in the map. In iPhoto Studio, we designed the intuitive UI to allow users to apply the cluster analysis as easy as possible. So first, we support different formats of data input. For example, we can use CSV, GeoJSON, H3 layer. We also provide many tools to help you to prepare data for cluster analysis. For example, the Shapify with special join and the special union. The UI is shown on the right screenshot, which includes a dimple layer. Then you can choose which variable for analysis, then specify how to define neighbors. Currently, we support nearest neighbor and distance-based neighbor. We also allow you to specify advanced parameters such as the number of permutation and then the thresholds value. So after this configuration, you can just hit the run button, and then the results will be shown in the table, and the map will be shown, and then to highlight the clusters. So next, I will do a quick demo to show the how to use cluster analysis in Studio to study the education disparity in the United States. So here we open iPhoto Studio, and then we click create a new map. And here we will use the iPhoto Studio, the data catalog, and we'll use some hex style that is available in iPhoto Studio. For example, here we scroll down, then we choose the ACS 2019 education hex style. This is the US census data. Then we click add data, and the data will be added. We'll see it's it has all the each hexagon will have the variables such as total population and the population of the people who has no high school degree or some with the bachelor degree, master degree, so on. So we will define the study area, which will be the mainland of the United States. So here we can use the toolbox, draw on the map, and we use the rectangle. Then we select the area that we want to study. And then you can zoom in a little bit, we see a little bit detail. We right click and then click extract the data. Then we can see here on the panel, it allows us to select which variable we want to use. So we will select total population, no high school population, and we'll compare into bachelor degrees, master degrees, and doctor degrees. And hit confirm, all the data will be saved in the new data sets. we hit the extra button, then the new data set will be created in a few seconds. Okay, so now the data set, now the new data set has been created that we show right here, extracted, and then you will see all the variables that we selected. And from here, we want to create a new column to represent the no education containment, which will use a formula to just simply use the sum of the education, the people with no high school degree divided by the total number of population. This will be has an easy variable for the low education we created. And then we can this, now we can create another column for our education containment. For here, we'll use the sum of the education from bachelor degrees and master degrees and doctor degrees. And we divide it by the total number of population. Then we create a lot of columns. So now we have two columns, which one is the higher education and the other is lower education. Then we click the analysis button. Then we on the panel we select cluster outlier analysis. From here we select input layer, which is we just extracted. And then first we select the low education variable, and then we choose the special weights by using 6 nearest neighbors because of the nature of the hexagons. And then we hit run. So all the things will be run in the browser in real time, and then the results will be shown in the table. Once you hit the confirm button, the class map will be shown, and then we'll do the same thing for the high education variable. We'll select the same thing for the 6 nearest neighbors, and the permutation will be 999, and p-values structure will be 0.05. Hit run, the same results will be shown on the table, and then a new map layer will be created. So to compare them, what we can do is we create a split map, which will here we click dual, and then we will just on the left side we show the low education map, and then on the right side we want to show the high education map. So from here we can already see some of the patterns, and to highlight the hotspots we can continue use the color scale. For example, here we just want to focus on the hotspots, so we will assign the same color for all other types. And then we'll hit confirm. There's a one here, and then we'll do the same thing on the no education cluster. Here, we click at the button, do the same thing. It's very easy to use. We just pick which color we want to use for different categories. Now we got the hotspots on the left side is for the low education hotspots. On the right side, we got hotspots for the high education populations. So we already can see some of the patterns over here. So on the Middle East, we got a lot of hotspots for low educations, but not see so much in the Middle East for the high education. And also for the higher education, we can see a lot of on the New York area. And if we want to check more, we can zoom in. This time we can just show the labels on the map, and we zoom in a little bit. For example, here we want to see why there's much difference here. Is the Texas? You can see a lot of hotspots of the low education in the south of the Texas, and a lot of high education clusters in the north of Texas. And if we move more, we'll see in Phoenix, in Arizona, here's a big hotspots for the low education. You can see here near Flagstaff. So this is a Native American area. You can see a lot of hotspots for low education, and then the high education cluster focus is you can see in the Flagstaff area and also the Phoenix metro area and the Tucson area. So you can see more by just zoom in and zoom out and change different parameters, and then this allows us to see more by using this tool. So in the next, we'll do more to add more. We will try to add more methods and focus on big data analysis using Hexstyle. So please stay tuned for any updates. Yeah, that's it. Thank you. I'll give it back to Katie.
Yeah, thank you so much, Shun and Ilya, and thank you all for joining, sticking around a little over time. Like I said earlier, we will be hosting a fireside chat over in our community Slack channel. You can join the conversation using the link on the screen. I will also put it in the chat below. We hope to see you at the next one. Thanks for tuning in.